So today we are starting chapter 6 in algebra, and we're going to be talking a lot about systems of equations. So in chapter 6, section 1, we're talking about graphing systems of equations. So make sure you have that down in your table of contents. And then flip over to page 58 and 59. Now, 58 for me, it's a lot of bleed through, so I'm doing it on an extra half sheet of paper, but I'm going to write on this side. All right, and so today we are talking about graphing systems of equations. So the first thing that we need to know is, what is a system of equations? I mean, if you don't understand what the terms are, then you're not going to be able to figure it all out. So a system of equations is just two or more lines. It can be more. The only one we're going to be doing is 2 lines. So we're going to be looking at 2 lines, and they want to basically know the solution. So the solution to a system of equations that is where the 2 lines cross. Or another word is where they intersect. And you have actually done this before if you've plugged the left into y1 and the right into y2 to calculate the intersection. You're essentially doing a system of equations. So basically what this means is that the x and y values will work for both equations. So that particular point where the 2 lines cross, that x and y, if you plug them in, it will make it true for both equations. Now, we're used to them just crossing and there's one answer. But there's actually more than that. So that's what we're going to look at next. So we're going to look at possible solutions. And I'm going to make a little table of, to find what the solutions are. So I'm going to kind of give it nice big, I want 3 rows going across, and then I want 4 going up and down. So I'm going to start by cutting it exactly in half, and then cutting each of these in half. All right. So I have my table, and we're talking about the number of solutions, or the possible solutions. And so the first thing we're going to look at is the number of solutions. We're going to look at terminology, which is going to be the hardest part of this. And then we're going to look and see what the graph looks like. The terminology is the only thing that's hard, because really, the answer is where the 2 lines cross. And that's the biggest thing that you absolutely need to know. So if there is exactly 1, meaning exactly 1 solution, then if I were to have a graph, now I'm going to go ahead and draw my little x and y axes over in both of these, or all 3 of these, sorry. The graph is going to look like, I have a line here, and I have a line here, and right there where they intersect is the solution. Now, the terminology for this, we would say that it is consistent and independent. And we're going to talk more about that terminology when we get to the second page. So just write that down for now, and I'll explain it in a minute. Now, there's more than just one possible solution. So if I have an infinite number of solutions, the terminology for that is consistent and dependent. And when you graph it, it looks like one line, and then the second line literally is going to be right on top of it. So it only looks like one line, even though you've graphed two things. And so therefore, it is an infinite number of solutions, because any point that's on that line would work as a solution. And then last but not least, you can have no solutions. Okay, because can you think of a time when you have two lines and they don't ever intersect? Hopefully you can think of parallel lines, right? So if you have parallel lines, they're never going to cross, so there's no solution. And then the terminology for this one is inconsistent. All right, so this is our table that kind of, because on the classwork, you're going to have to, do the consistent and independent, consistent and dependent, all of that. And so that's what's going on page 58. So for me, I'm gluing this down. But now let's talk about the terminology a little bit, okay? So if it's inconsistent, which is the one we just talked about, inconsistent means there are no solutions. And the way that that works, if there are no solutions, then they are parallel lines. The other term that we're going to talk about to begin with is consistent. Now, if it's consistent, then there is at least one solution. So when you're trying to name these and classify them, the first thing that you're going to do is you are going to pick one of these two terms. It's either inconsistent or it's consistent. So you pick one of those. Now, if it's consistent, then you're going to pick one of the following. So if it's inconsistent, that's the only term that's going to go with it. So if you see something that says it's inconsistent and dependent, or inconsistent and independent, those are not the right answers. You can immediately rule those out because that makes no sense. Inconsistent just means there's no solutions, so the other terms don't mean anything. However, if it's consistent, you need to decide, is it dependent? And dependent means that basically one line depends on the other. It's the same line. So there is an infinite number of solutions. And basically it is the same line drawn on itself. Okay. So if it's consistent, we then either have to, excuse me, we have to say it's consistent and dependent, or we say it's consistent and independent. Now, if the lines are independent of each other, then that means that one of them, it doesn't matter, you know, what the second one is, they're separate. So this is just the two lines cross somewhere, and there's exactly one solution. So you can have two lines that cross, two lines that never cross, or two lines where one of them is drawn right on top of the other. And you need to know this terminology. So if they're parallel lines, it's just inconsistent. If there's at least one solution, it's either consistent and dependent, if there's an infinite number, or consistent and independent. So the answer to the next question is Venus, and I'll see you next time.